Okay, I want you to picture the internet for a second.
Right.
And I don't mean, the curated Instagram feeds or the high-production YouTube video.
Shiny stuff.
Exactly. I mean the text. The sheer, unmanageable waterfall of words that gets typed into the void every single day.
Oh, it's a flood. We're talking millions of product reviews, angry tweets, these huge forum posts. It's just raw human opinion.
And that's the thing. If you're a business, say you make cars or smart fridges, that waterfall is a gold mine.
A total gold mine. You desperately want to know what people think. But here's the massive problem. You cannot hire an army of people to read 10 million tweets. It's just not possible.
Right. You'd need a stadium full of people just reading comments all day. So naturally, the world turned to automation. You need a machine to do the reading.
Exactly. And that brings us to the world of sentiment analysis.
Which is basically teaching a computer to read a sentence and figure out, is this person happy? Are they angry? Or are they just bored?
But here's the catch, and it's really why we're doing this deep dive. For a long time, the tools we used were, well, let's be honest, they were pretty dumb.
Blunt instruments.
Blunt is putting it politely. Historically, these systems will look at a document, maybe a whole sentence, and just try to slap one sticker on it. Positive, negative. That's it.
But we don't talk like that.
Yeah.
Human speech isn't binary.
No, we're messy, we're conflicted, and this is where we hit the nuance gap.
And the source material has this perfect example. Imagine you're reading a product review and the user writes, I like the design, but the interface looks strange.
Right. And if you're an old school sentiment tool, you just panic. You see like, which is good. You see strange, which is bad. So what do? Average them out to 0.
And if you average it to neutral, you've completely failed.
Yeah.
Because that user is not neutral. They have two very strong, specific opinions in the same breath.
Exactly. They love the hardware, but they hate the software. If you tell your engineers the user is neutral, you've lost all the insight.
So today we're going to fix that. We're digging into a fascinating paper called Towards Well-Grounded Phrase-Level Polarity Analysis. It's from 2011 by Robert Remus and Christian Hennig.
From the University of Leipzig. And I have to say, I love that it's based on German research.
Oh, for sure. If you want to test if a computer can understand complex grammar and sentences that just run on forever, German is the ultimate obstacle course.
It really is. The logic was, if they could build a system, what they called the polarity composition model, that worked for German, the principles would probably hold up for anything else.
So their mission was to stop looking at the whole sentence and start looking at the phrases, the little building blocks.
And to do that, they developed a 2-layer approach.
Okay, let's peel this back. What's layer 1?
Layer 1 is the foundation. It's what they call word-level polarity. Before you can understand a complex thought, you have to understand the ingredients, the words themselves.
So this is like giving the computer a dictionary, but instead of definitions, it's a dictionary of feelings.
Precisely. They used a tool called CentiWS. It's a huge German dictionary where words aren't just defined, they're scored. Every emotional word gets a value, let's call it V, between -1 and 1.
So -1 is like the absolute worst thing imaginable.
Complete disaster, pure hatred. And +1 is pure joy.
Okay, so if I feed it the word good, what does it see?
It sees a number, maybe a 0.4. But if you feed it fantastic, it might see a 0.8 or 0.9. The higher the absolute number, the more expressive the word is.
So it's quantifying the volume of the emotion.
Exactly. And they break these words down into 2 buckets. You have your potential polar categories, the meat and potatoes, nouns, verbs, adjectives.
Words like car, drive, beautiful, crash.
Yes, those carry the feeling. But then you have the second bucket, which is where things get interesting. The modifying categories.
The spices.
The spices, yeah. They don't mean much on their own, but they change the flavor of everything they touch. We're talking about words like not, no, never.
Or very, extremely, rarely.
Correct. Negations and intensifiers.
Okay, so layer 1 gives us the raw score of the words in isolation. But we don't talk like that. We speak in chunks.
And that is layer 2, phrase-level polarity. This is where the paper gets brilliant. They realized you have to understand how those modifiers, what linguists call contextual valence shifters, actually warp the math of the sentence.
Valence shifters. That is such a cool term. It sounds like something from a starship. Captain, the valence shifters are destabilizing.
It does sound sci-fi. But valence just refers to whether something is good or bad, and shifters are the things that move that needle.
And this is where they found something that really challenged the conventional wisdom at the time. There was this big assumption in tech called the flippin' myth.
Oh, this is a huge concept. For years, engineers just assumed sentiment was like a light switch. If good is +1, then not good must be -1. You just flip the sign.
It makes perfect logical sense. If I'm not happy, I'm sad. It's binary.
But are you? Psychologically?
No, not necessarily. I could just be, meh. I could be bored.
Exactly. And that's what Remus and Hennig latched onto. They argued for effective asymmetries.
Okay, effective asymmetries. Fancy way of saying our feelings aren't perfectly symmetrical.
That's all it is. Let's try an example. You say, that movie was good.
Clear positive.
Right. High score. Now, what if you say, that movie was not bad?
Is that the same as saying it was good?
What do you think?
Definitely not. Not bad is?
Mm.
It's passable. It didn't ruin my night. But I'm not running out to buy the DVD.
Precisely. X is good is significantly more positive than X is not bad. The negation didn't just flip it to its opposite, it dampened it.
And I assume it works the other way too. Bad versus not good.
Yes. That was bad is a strong condemnation. That was not good is a bit of a softer way of saying it wasn't great. Bad is much stronger.
So positivity and negativity aren't mathematical opposites. They have different weights in our brains.
And if you're building a computer model to replicate that, you can't just swap the plus and minus signs. You have to account for that dampening effect.
So how do they do it? How do you teach a robot that not bad is just meh?
You have to move from simple addition to what they call rule-based modeling. They created a specific set of multipliers.
Okay, lay the math on me, but keep it simple.
It's actually quite elegant. Let's look at intensifiers first. If you use a strengthening word like very, or in German, sehr, they multiply the score of the adjective by 1.5.
So good becomes 50% stronger. It cranks the volume up.
Right. But if you use a weakening word like rarely or somewhat, they multiply it by 0.5. They cut the emotional strength in half.
That makes intuitive sense. But what about the not bad problem? How do they handle the not?
This is the key takeaway here. When the system sees a negation like not, it multiplies the score by negative 0.75.
Negative 0.75. Okay, let me work that out. The negative sign flips the emotion, so positive becomes negative.
Correct. That handles the direction change.
But the 0.75, that means the result is only 75% as strong as the original? It shrinks the value?
Bingo. It mathematically captures that feeling of not bad. It flips bad to the positive side, but because of that 0.75 multiplier, it keeps the score lower than a pure good.
That is surprisingly clever. It turns a linguistic nuance into a hard number.
It is,
Yeah.
but multiplication is the easy part. The real headache starts when you have to do addition.
Addition, you mean when you have multiple words in a row?
Exactly. What happens when you combine two words that both have feelings attached? If I say beautiful, happy day, that's easy. Positive plus positive. You just add them up.
But we have mixed feelings all the time.
Yes, the clash. What happens when one word is positive and one is negative?
Give me an example from the study.
They used a fantastic German phrase, übertriebene Pflege.
Übertriebene Pflege. So, exaggerated care?
Now break that down. Care or maintenance is generally a positive concept, right?
Sure, I want my car to have care. But exaggerated. That feels negative. It feels like too much, like smothering.
So you have a negative adjective modifying a positive noun. Who wins that fight? Does the positive outweigh the negative? Or does the negative taint the positive?
My gut says the negative wins. Exaggerated care sounds annoying.
And your gut is right. They ran human surveys on this. They showed people these mixed phrases and found that when positive and negative mix, the result is almost always negative.
It's the bad apple spoils the bunch rule.
Linguists call it negativity bias. We're evolutionarily wired to notice the threat, the flaw. So, Remus and Hennig rigged their math to match our brains.
How did they rig it?
When there's a clash, the model doesn't just average the two numbers. It actually subtracts the larger value from the smaller value. It forces the math to come out negative.
They put a thumb on the scale for negativity.
They did. And the data backed them up. Their survey showed that 73% of these mixed pairs were judged as negative by humans.
Okay, so we have a model that understands not is a dampener, and that mixed feelings usually mean bad feelings. This all sounds great in theory.
But theory is useless if it doesn't work on actual messy internet comments.
Which brings us to the evaluation. Man versus machine.
And here they ran into a classic 2011 problem. There wasn't a good data set for this kind of phrase-level German sentiment, so they did what any good scientist does.
They built their own?
They built their own, and I love where they went for the data. Automotive forums.
The Colosseum of opinions. People take their cars very seriously.
They picked two topics. First, the Mercedes-Benz W212, the E-Class.
Symbol of luxury.
And topic number 2, rust.
Rust.
The ultimate enemy of the car enthusiast. Such a great contrast. One is aspirational, one is pure decay.
So they scraped thousands of sentences and then filtered them down to about 477 complex ones. Then they had humans read and rate them. And this brings up a really uncomfortable question.
Uh-oh. What is it?
How much do humans actually agree with each other?
We tend to assume there's a right answer. But emotion is subjective. They measured the agreement between their human raters using a stat called Cohen's kappa. For individual words, the agreement was 0.76. Pretty solid.
Okay, so we mostly agree that rust is bad and luxury is good.
But for phrases, for the complex stuff, the agreement dropped to 0.58.
Oof, 0.58. That's barely better than a coin flip. That means the humans were looking at the same phrase and arguing about its feeling.
It just shows how hard this task is. But using the human consensus as the answer key, they tested their new model against a baseline.
And the baseline was the old way, just adding up word scores.
Yep. And the polarity composition model, the one with the fancy multipliers, it destroyed it.
Give me the numbers.
At the phrase level, the F measure, which is a blend of precision and recall, improved by about 22%.
22% is a massive leap in data science. People usually fight for 1 or 2%.
It's huge. It proved that you can't just treat a sentence like a bag of words. You have to respect the structure, the not, and the very.
So, victory lap. Did we solve sentiment?
I wish. But this is language we're talking about. There's always a catch. The paper is very honest about where the model breaks.
Let me guess. It breaks when we stop being literal.
Exactly. Sarcasm and irony. The arch enemies. The paper mentions the phrase, good night. Good night.
Which is polite. I say to my kids, good night, sleep tight.
Sure. But imagine you're in an intense forum argument about spark plugs, and the other guy finally replies, oh, just forget it. Good night.
Yeah. That's not a wish for pleasant dreams. That means I'm done with you, or we're doomed.
Right. But the model sees good and thinks, hey, positive word, +1. It misses the situational irony completely.
Another one they mentioned was, oh, great.
Yep. Your car breaks down on the side of the road, steam everywhere, you kick the tire and say, oh, great.
The model thinks you're thrilled about the breakdown.
It has no concept of the situation. It only sees the dictionary definition.
There was another limitation I found really interesting, the presence versus absence issue.
This is fascinating. It goes back to the rust topic. Consider the sentence, rust is not present.
Okay, let's do the math. Rust is negative. Not is a negation.
So if you use the Nanico 0.75 multiplier, not rust becomes a positive value.
Which is correct. No rust is a good thing.
Conceptually, yes. But mathematically, remember the dampening effect. Because the model multiplies by 0.75, it treats no rust as a weak positive.
Ah, I see. But no rust isn't a weak positive, it's a fantastic positive.
Exactly. The absence of a bad thing is a strong good thing, but the model treats it more like a lessened bad thing. It needs a special category for absence to really get that logic.
It's like the computer needs to learn that the enemy of my enemy is my friend.
That's a perfect way to put it. And finally, there's the confusion of relative adjectives. Take the word big.
Okay, big. Is it positive or negative?
Well, it depends. Big bonus is good. Big mistake is bad.
Right.
Sometimes big is just a multiplier that intensifies the word next to it. But what if I say, this news is big?
Then big stands on its own. It means significant, important.
So the model has to figure out, is big acting as a servant to another word? Or is it the hero of the sentence? The syntax gets really tricky there.
So let's zoom out. We've got a model from 2011 that was a huge step forward. It stopped using blunt instruments. It understands that not bad is nuanced, that exaggerated care is annoying, but it still trips over sarcasm.
Which, to be fair, is true of some humans I know.
Fair point. So why does this paper matter to us today? Why read a 2011 paper about German grammar?
Because it laid the groundwork for what we now call topic-centric sentiment.
Topic-centric. Break that down for me.
Think about it. Before this, a review was just a big blob of text. With this phrase-level approach, businesses could finally see what specifically is working.
So instead of just user X is 60% happy, it can say user X loves the engine, plus zero point 0.8, but hates the paint job, zero point 0.9.
Exactly. It separates the sentiments within the same sentence. That turns a star rating into actionable data. You know exactly what to fix.
That is the game changer. It's not just people are mad. It's people are mad about the rust, but they're willing to forgive the price.
It moves us away from intuition towards validation. They didn't just guess that not flips the polarity. They tested it. They surveyed people to prove it.
It really highlights how complex our daily language is. We just take for granted that we can decode not bad or oh great instantly.
And it leaves us with a bit of a philosophical question. Remember that human agreement score we talked about? The 0.58?
The one where the humans couldn't agree on the phrases?
Yeah. The paper mentions a sentence where the raters split. It has less rust than the other car.
Oh, that is tricky. Is that positive because it has less rust? That sounds good.
But is it negative because it still has some rust?
Right. It's like saying this sandwich has less mold than that sandwich. It's not exactly a compliment.
Exactly. It's a matter of perspective.
Yeah.
And here's the kicker. If two humans can look at that sentence and feel two different things, can we ever expect a computer to get the right answer?
Maybe there isn't a right answer. Maybe emotion isn't a math problem you can actually solve.
It suggests that at a certain point, sentiment analysis stops being about accuracy and starts being about interpretation. We might be asking the machine to do something we can't even consistently do ourselves.
That is a comforting thought for those of us worried about AI taking over. They might calculate the trajectory of a rocket, but they'll never understand why we're being sarcastic about it.
We'll always have that over them.
That's a wrap for this deep dive into the math of emotion. Thanks for exploring the nuances of German grammar and the logic of feelings with us.
My pleasure.
See you next time.